In this video, we are going to review what we learned about linear functions. So the first thing that we're going to talk about is an equation. And so remember, an equation is a mathematical sentence that contains an equal sign. So the biggest thing to remember is that equations have equal signs. And then with linear functions, we also learned about linear inequalities. And so an inequality is a mathematical sentence that contains an inequality symbol. And so the inequality symbols that we learned were less than or equal to, less than, greater than, and greater than or equal to. So here we are solving equations and inequalities in one variable. So if I look at -7 minus 6x is equal to -3 minus 4x, right now, I have variables on either side of my equal sign. I need to get them on the same side. So to undo subtraction, I'm going to do addition. And I'm going to add 4x to both sides. When I do that, I'm going to bring down my -7. -6x plus 4x is -2x. I'm going to bring down my equal sign and the -3. -4x plus 4x is 0. I want to get -2x alone. Right now, I have a -7 in front of that. I need to move that -7 to the other side. So to move a -7 to the other side of the equation, I need to add it to both sides. -7 plus 7 is 0. I'm going to bring down my -2x and my equal sign. -3 plus 7 is 4. I want to get x by itself. X is being multiplied by -2. To undo multiplication, I'll do division. -2 divided by -2 is +1, so that just leaves me with +1x. And 4 divided by -2 is -2. So my answer is x equals -2. On this next one, it says solve and graph inequalities. So I have this inequality, 5 times the quantity of 7 minus 6x is greater than or equal to -175. So the first thing that I'm going to do is I'm going to distribute. 5 times 7 is 35. And 5 times -6x is -30x. I'm going to bring down my less than or equal to symbol and the -175. I want to get -30x by itself. So I need to move the 35 to the other side. The 35 is positive, so to move it to the other side, I am going to have to subtract it. 35 minus 35 is 0. I'm going to bring down my -30x and my greater than or equal to symbol. And then I'm going to do -175 minus 35. And when I do that, I get -210. To undo multiplication, I'm going to do division. And so I'm going to divide both sides by negative 30. Negative 30 divided by negative 30 is positive 1. So that leaves me with a positive 1x. Whenever you multiply or divide by a negative number, you must flip your inequality symbol. Negative 210 divided by negative 30 is positive 7. So my answer is x is less than or equal to 7. To graph this answer, I'm going to put 7 in the middle of my number line. I have x is less than or equal to 7. 7 is included as a part of my answer, so 7 is going to get a closed circle. And then I want all the numbers that are less than 7, and so I am going to shade to the left. And so that is what the graph of the solutions would look like. We also learned how to graph linear equations and inequalities on a coordinate plane. We learned about slope-intercept form, which is y equals mx plus b. M is the coefficient of x, and that represents your slope. You can find the slope by using rise over run if you're given a graph. Or you could find the slope by doing y2 minus y1 over x2 minus x1 if you're given 2 points. B represents the y-intercept. And so that's the point where it crosses, where the line crosses the y-axis. So let's try graphing this example. We have y equals 2x minus 4. So I'm going to begin with b. B is my y-intercept, and in this case, that is negative 4. So I'm going to go to 1, 2, 3, negative 4 on my y-axis, and I'm going to plot that y-intercept. Our slope, m, is 2. So I'm going to move with m. If my slope is 2, I can make this a fraction by putting the 2 over 1. So that means that I can rise 2 and run 1. So up 2 to the right 1. Up 2 to the right 1. And I'm just going to keep doing that all the way up my graph. If we had room going the other direction, we could also go down 2 and to the left 1. Once you have all the points that you like, remember that all you need is 2 points to create a line. And we'll draw our line connecting those points. So that is the graph of the line y equals 2x minus 4. The same exact rules apply for inequalities. So again, I am going to begin with b. Here b is positive 1. I'm going to move with m. My slope is negative 3/4. So that means that I can go down 3 and to the right 4. So 1, 2, 3, 1, 2, 3, 4. I could also go up 3 and to the left 4. So 1, 2, 3, 1, 2, 3, 4. And then I can connect these points in a line. Remember, lines go on forever, so don't forget to include your arrows. Because my equation, or sorry, my inequality is less than, I'm actually going to have a dashed line. And so I'm just going to put dashes in this line. Because any point on this line is not included in the solutions. And then also because it's less than, we are going to shade below this line. And so if I shade below this line, that's going to be everything down here. Let me make that shading a little bit better. And so remember, with inequalities, your solutions are on solid lines or in shaded areas. So in this case, our solutions would all be in this purple shaded area. We can also write equations in slope-intercept form. And to do that, your first step is going to be to find the slope. And when you're given 2 points to find the slope, I'm going to use the slope formula right here. And so I like to label my points x1, y1, x2, y2. And so to find the slope, I'm going to do y2 minus y1 over x2 minus x1. So in this problem, this first negative symbol comes from the formula, and the second negative comes from the fact that the number itself was negative. So 5 minus negative 4, a negative times a negative is a positive. So 5 plus 4 is 9. And then over here, a negative times a negative is a positive. So negative 2 plus 5 is 3. 9 divided by 3 is 3. So the slope of this line is 3. The second thing that we want to do is we want to find the y-intercept. And so to do that, we're going to solve for b. And I'm just going to plug in to y equals mx plus b to be able to do that. So you're going to pick one of your points, and it doesn't matter which one. I'm going to choose the second one. So if I choose the second one, y is 5. M, well, we just solved that right here in this equation. That's 3. If I'm using this point right here, then x is negative 2 plus b. So 3 times negative 2 is negative 6. To undo subtraction, I'll do addition. 5 plus 6 is 11. So our y-intercept b is 11. Your third and final step is to write the equation of the line, replacing your slope m with what you found in step 1, and replacing your y-intercept b with the y-intercept you found in step 2. So the equation of this line is y equals 3x plus 11. With linear functions, we also learned about linear systems. And so we learned 3 methods for solving a system of equations. In the first method we learned was graphing. So I'm going to begin by graphing the first line that we are given. And that first line is x equals 4. Whenever you have x equals a number, remember that that is a vertical line. So x equals 4 right here. And so I'm going to have a vertical line going straight up and down at that point. And then for our other equation, we have y equals negative 3/4 x minus 1. So I'm going to begin with b. B is negative 1. I'm going to move with m. My slope is negative 3/4. So that means I'm going to go down 3 and to the right 4. I could also go up 3 and to the left 4. And then I'll connect those points in a line. Whenever you're doing this, you're looking for the point of intersection. So you're looking to see where the two lines meet. Here, our two lines meet at this point right here, which is the point 4, negative 4. So that ordered pair is my answer. We also learned how to solve linear systems by substitution. And so for the substitution method, one of your equations either needs to be y equals something or x equals something. In this problem, I have y equals 3x minus 5. So I'm going to take what y equals in this first equation and plug it in to y in this second equation. And so to do that, I'm going to have 3x minus 6 times y. And we know that y is 3x minus 5. And that's going to equal 15. So instead of writing y, I've just replaced y with what y equals. So now I can bring down my 3x. Negative 6 times 3x is negative 18x. And negative 6 times 5 is positive 30. And then I'm going to bring down my equal sign and the 15. From here, this is just a regular equation that we can solve. And so I'm going to combine like terms. 3x minus 18x is negative 15x. I want to get negative 15x alone, so I need to move this 30 to the other side. To undo addition, I'll do subtraction. And so I'm going to bring down my negative 15x. 30 minus 30 is 0. I'm going to bring down my equal sign. 15 minus 30 is negative 15. To undo multiplication, I'll do division, and I'll get x is equal to 1. Remember that we're looking for the ordered pair where these 2 points meet. And so my solution is going to be an ordered pair. Right now I know the x-coordinate of my solution is 1. I still need to find the y-coordinate. And so what I'm going to do is I'm going to plug in 1 into our first equation to solve for y. So we just found that x was 1. 3 times 1 is 3. 3 minus 5 is negative 2. So my solution is 1, negative 2. So if we were to graph this system, these two lines would cross at the point 1, negative 2. The third way that we learned how to solve a linear system of equations is using the elimination method. And for the elimination method to work, one of your variables needs to eliminate when you add them together. Right now, when I look at this problem, nothing's going to eliminate. But I can multiply this equation. If I want to eliminate the x's, what I could do is I could multiply this equation by negative 2 to get negative 14x and positive 14x, and I could cancel these out that way. If I wanted to eliminate the y's, I could multiply this bottom equation by negative 9. And then I'd have a positive 9y and a negative 9y, and then the y's would eliminate. It's totally up to you and however you want to do it. I'm going to choose to eliminate the x's, and so I'm going to multiply this top equation by negative 2. And when I do that, I'm going to have negative 14x minus 18y is equal to positive 54. That bottom equation didn't get multiplied by anything, so that bottom equation is going to stay the same. Now that a variable is going to eliminate, I can add these two equations together. Negative 14x plus 14x is 0. The x's have eliminated, which is what we wanted to happen. Negative 18y plus y is negative 17y. And 54 minus 3 is 51. To undo multiplication, I am going to do division. And so I am going to divide both sides by negative 17. And I'm going to get y is equal to negative 3. Now that I know what y equals, I can plug that into one of my two original equations to figure out what x equals. I'm going to choose to plug into this bottom equation. And so I'm going to have 14x plus, and then instead of writing y, I'm going to write what y equals. Negative 3, and that's going to equal negative 3. So it's really like I have 14x minus 3 equals negative 3. To undo subtraction, I'm going to do addition, and I'm going to add 3 to both sides. And so I'm going to have 14x is equal to 0. To undo multiplication, I'll do division, and I'll get x is equal to 0. So my solution is the ordered pair 0, negative 3. So if I were to graph these two lines, this would be the point of intersection. We can also have a system of linear inequalities. And so when I look at this first inequality, I have y is greater than or equal to x minus 1. I'm going to begin with b. Here b is negative 1. I'm going to move with m. Here my slope is positive 1. So I'm just going to go up 1 to the right 1. I can also go down 1 and to the left 1. It's greater than or equal to, so this is going to be a solid line. And it's greater than, so I'm going to shade above this line. So that's going to be up here. All right, and then for our other equation, we have y, we have y is less than negative 3. Here, we do not have an x. So when you have y and no x, that is when you have a horizontal line. So y equals negative 3 right here. It's going to be a dashed line because it's not equal to. And then because it's less than, we are going to shade below. So our solutions are where the two shaded areas meet. And so that's this triangle right here. So all of our solutions exist in this area where the shaded regions overlap. So there's three different types of solutions that you can get with a system of equations. You can get no solution. And no solution will happen when you have parallel lines. So remember, parallel lines have the same slope. So for ease of this one, I'm just going to choose a slope of 1. And I just started where my y-intercept was 3. And then for the other one, I'll start where the y-intercept is 0. So if your lines have the same exact slope, then you will have parallel lines and they will never intersect. And so your answer will be no solution. One solution is like the examples that we did above, where your two lines will cross in one place. And so let's do something like this. So let's say I have the slope of 3/2. I'm going to start at 0, 0. I'm going to go up 3 and to the right 2. I could also go down 3 and to the left 2. And then let's say my other equation has opposite slope, so -3/2. So here I have one solution, and that one solution is where the two lines intersect, and that is at 0, 0 for this case. So one solution is when you have intersecting lines. You could also have infinite solutions, and that is when you have the same exact line, one line on top of the other. And so I can have an example like this. So here's one equation. And then my second line is just the same exact line directly on top of it. And so when this happens, you're going to get infinite solutions because the points are intersecting at every single point. And then we also learned about functions. And so it says evaluate f of x equals 4x minus 11 for f of -2. This is telling you that x equals -2. So every time you see an x in this equation, you're going to replace it with -2. So I'm just going to replace all of the x's with -2. So remember that this side over here is just notation. This is telling you to look at the function f of x and plug in -2 for x. This side is what we are working with. This is what we're trying to find. And so from here, I'm just going to use the order of operations. 4 times -2 is -8. -8 plus 11 is -19. So f of -2 is -19. Then we have the vertical line test. And it says, are the following graphs functions? So remember, for your vertical line test, imagine drawing a vertical line and then taking that vertical line and moving it back and forth across your function. If it touches that line more than once at one location at a time, then it's not a function. So here I'm touching the line in one place, one place, one place, one place, one place, one place, one place. So I'm never touching more than one spot at a time, so this is a function. If we try that on this example, if you look, I'm touching the circle in two spots at the same time. So this does not pass the vertical line test, And so this circle is not a function. And then we want to know if this mapping is a function. And so here this is telling me that 1 goes to 8. So it's like it's telling me I have the ordered pair 1, 8. And then I have 2 maps to 4. So that's like I have the ordered pair 2, 4. And then 3 maps to 9. So that's like I have the ordered pair 3, 9. For it to be a function, all of your x coordinates have to be unique. They are all unique, so this mapping is a function. If I look at my table of values, I have -1, 8, 3, 1, 5, 2, and 3, 1. Let's make this a little bit more easier to see. So let's make this 3, 2. So it'll be 3, 2 on your paper. So here 3 goes to 1 and 3 goes to 2. This x value of 3 is going to 2 different y values. And so this is not a function because 3 is going to 2 different places. And then we have characteristics of linear functions. And so we're going to go ahead and graph y equals -2x minus 4. So I'm going to begin with b. b is -4. I'm going to move with m. My slope is -2. So that means I could go down 2 into the right one, but I don't have enough room. So instead I'm going to go up 2 and to the left one. This is an equation, so I'm just going to have a solid line with no shading here. And now I can find these characteristics. Your domain are your x values from left to right. My graph is going to the left forever. My graph is going to the right forever. So my domain is -infinity to +infinity, or you could say all real numbers. Your range is your y values from the bottom of your graph to the top of your graph. My graph is going down forever, so that's going to -infinity. My graph is going up forever, so that's going to +infinity. So my range is from -infinity to +infinity, which is the same thing as all real numbers. Your x-intercept is the ordered pair where it crosses your x-axis. So that's this point right here. That's the point -2, 0. Your y-intercept is your point where it crosses your y-axis. That's this point right here, at the point 0, -4. To figure out if your graph is increasing or decreasing, you're going to trace your line from left to right. From left to right, this graph is going down, and so this is a decreasing graph. And then for end behavior, as x approaches -infinity, this is telling you to look at the left side of your graph. The left side of our graph is pointing up, so that's telling us that it's going to +infinity. As x approaches +infinity, this is telling you to look at the right side of your graph. The right side of my graph is pointing down, and so that is going to -infinity. And the last thing that we learned about with linear functions were arithmetic sequences. For arithmetic sequences, we learned about the recursive formula and the explicit formula. So the recursive formula is a sub m equals a sub n minus 1 plus d, where the first term is given. And the explicit formula is a sub m equals a sub 1 plus d times n minus 1. Or sometimes I write it the other way, a sub m equals a sub 1 plus n minus 1 times d. So you can see it written either way. Let's write the recursive formula first. So remember that a sub 1 is your first term. So here my first term is 1. And D is your common difference. That's how much you're adding or subtracting by every time. Because remember, arithmetic sequences is when you're adding or subtracting by the same amount every time. So to go from 1 to 6, I add 5. 6 to 11, I add 5. 11 to 16, I add 5. And 16 to 21, I add 5. So my common difference D is 5. So my recursive formula would be A sub m equals A sub n minus 1 plus 5, where the first term was 1. If I look over here at my explicit formula, here my first term is 23. To go from 23 to 21, I subtract 2. From 21 to 19, I subtract 2. And from 19 to 17, I subtract 2. So my common difference D is negative 2. So my equation would be, if I do the top one, I would have A sub m equals my first term, which is 23, plus my common difference D was negative 2. So I can put that inside parentheses, and then n minus 1. Or if you'd like, you could write it the other way. So if you wrote it as a bottom way, that'd be A sub m equals 23 plus n minus 1 times negative 2. So however you want to write it, these two equations mean the same thing. So we learned a lot with linear functions, but that is a very basic review of everything we learned in our linear functions unit.